In this section, we're going to be talking about chemical properties and then touch on some chemical changes or chemical reactions. So, chemical properties come in several different forms. So, a chemical property basically describes how a substance changes into a new substance. So, we'll go through these in the next couple chapters, but chemical reactions or chemical properties happen, or they change whenever two different substances come together and they actually react. So you're going to have, well, it doesn't have to be two different substances, but you're usually going to have more than one substance basically bumping into each other, and then that causes a chemical reaction to create new substances or a new substance. So that deals with the chemical reactivity. So a chemical property is the reactivity of the substance. So reactivity in this case means the capacity of a substance to combine with another. Okay, and that will create new compounds, new compound, so on and so forth. Also flammability. So combustion reaction or something burning is actually a specific type of chemical reaction that we'll go into. So something's ability to burn is actually a chemical property. Toxicity. So objects or different substances are toxic because of the reactions that they can create inside of the body. Okay, so toxicity is another example of a chemical property, and also radioactivity. So radioactivity involves usually the breakdown of the nucleus of an atom, which then produces different particles that go out from the nucleus and cause other reactions in the things that they bump into. So radioactivity, toxicity, flammability, and reactivity are all chemical properties. So these are a bit more abstract than the physical properties. They're a little bit harder to kind of conceptualize. So when we're looking at physical versus chemical properties, okay, so it's got three different examples here. First up, we have wood. So physical properties, you might say that it's brown, it has a grainy texture, you know, it's relatively solid, you know, things like that. But chemical properties, it is flammable. Okay, obviously we know that about wood. It is also pretty easy to see that there is a chemical reaction taking place when wood is burned because the wood changes color, goes from a brown to black. Okay, now with the iron, okay, so some physical properties, it is a metal, so it would conduct electricity. It would also transfer heat through it. If it's not rusty, it's a silvery color. In this case, it's kind of a brownish red color. It bends without breaking. It would be malleable, ductile, all different properties of metal. Okay, but those are physical properties. So chemical properties have to do with its reactivity. In this case, it can react with oxygen to form rust. Okay, so iron itself is usually a silver color, and it only turns this reddish brown once it starts to rust. So that is an example of a chemical property. And then we have red dye. So in this case, physical property, it's red in color. Okay, pretty obvious because it's a red dye. Chemical property deals with, it actually dyes the fabric. Okay, so that is a chemical property. It causes a color change in the fabric. It also reacts with bleach. Okay, that is another chemical reaction, chemical property. Okay, is that it changes color once it's exposed to bleach. Okay, so a physical change affects one or more physical properties of a substance without changing the identity of the substance. So you can change the size, you can change the polish, things like that, but you cannot change the identity of the substance. So if you have compound 1 going into this physical change, you're going to get compound 1 exactly the same out. Okay, it might be in a different form. Okay, so like if you have H2O going in, you're going to get H2O coming out. It just might be water going into the physical change and then ice coming out of the physical change. Okay, so some physical changes include melting, boiling, crushing something, cutting it, grinding it, or dissolving it. Okay, so all of these are physical changes. They will not actually change what the substance itself is. Sometimes it can make it easier for other chemical reactions to take place, but at this point, these are just physical changes. Chemical reactions, chemical changes, more often known as chemical reactions, will actually change the identity of a substance. So it can combine different substances, split a substance into pieces, or a combination of a lot of different reactions. So the resulting substances or substance will have different properties than the original substance or substances. Okay, so you're going to get one or more compounds coming in and then a completely different set of compounds coming out of this reaction. Okay, so rusting would be an example of this. You have just iron going in, okay, and then it reacts with oxygen in the air. So it's a reaction between iron and oxygen, and it produces iron oxide. Baking is another really good example of this. Okay, so you combine all of your ingredients, okay, and then mix them all up really nice and good, and add heat, and then all of a sudden you've got all of these different chemical reactions taking place, especially if you're baking bread. You get the rising, okay, it's actually producing carbon dioxide gas, right, so that's what causes bread to rise. That thankfully escapes from the bread, so you don't have to worry about eating that. So don't freak out about carbon dioxide in your bread. But so these, there's actually a couple videos that go along with this. This is something that I find really interesting. I don't necessarily know why, but I've always been interested in glass blowing. And I was actually in Italy my sophomore year of high school on a choral tour and got to basically talk with a glass blower in Venice. And Venice is really known for their Venetian glass is what it's called. It's this light purple colored glass. And so we actually started talking about different compounds that you add to the glass in order to get different colors. And so, I mean, it's just really interesting to me. So they just add different compounds, and most of them, as you can see, are oxides. Okay, that just causes a better reaction in the glass as it's forming. So you can see the purple, the Venetian glass here is manganese dioxide. Okay, one of the most expensive colors to get in glass is actually red, because they use gold chloride in order to get that nice bright red color in it. But you can see that there's a lot of different compounds that they'll use in glass just to get various different colors. And some of this goes down to, the amount of each compound they use, so on and so forth, and like the heat involved, and if they're mixing any compounds, things like that. But it's actually a really interesting thing to look into. So we've got the two videos about glass blowing, and one of them is on one of the most famous glass blowers at the moment. His name is I can never say it right, Kahuli, I think. I don't know. But he does some really interesting stuff, and that is all based in chemistry. It's mixing different compounds in order to get the mixture that you need to actually melt down to produce the glass. And then, yeah. I just think it's really cool. But alright, so a couple signs or a couple examples of some chemical reactions here. So this isn't really something that we see around here all that much, but back in the southeast where I'm from, you would see, starting around this time actually, you would see the leaves start to change. So you get a chemical reaction inside the leaves that produces pigments that give the leaves their colors. So in the fall, the green leaves will change colors as different reactions take place. And a lot of that is driven by the temperature. Okay, so once it's cold enough for long enough or cool enough for long enough, the green pigment actually starts to degrade, which means that these other pigments start to show up more vibrantly. And it's kind of the plant's last-ditch effort to get some stored energy for the winter before the leaves just fall off the tree completely. So those are different chemical reactions taking place. If you've ever used like Alka-Seltzer or anything like that, those are these effervescent tablets. So when you add those to water, you get citric acid and baking soda that's in these tablets will actually react inside the water and produce carbon dioxide, which forms the bubbles. Okay, that's why it kind of starts to look more like a soda because it's so bubbly. Okay, same kind of concept. The bubbles in your soda are also carbon dioxide. And then talking about copper, okay, so the Statue of Liberty used to be that nice coppery color, but it reacted with the carbon dioxide and water in the air to form this green-blue color that we're all familiar with the Statue of Liberty. Okay, so it is actually supposed to be, you know, copper colored, but that, you know, doesn't work well in the elements. Alright, so a couple examples, or a couple indications of chemical reactions. So if you get bubbles forming in a solution, okay, that is an indication that you are, that you have a chemical reaction happening. Oftentimes that will be things like carbon dioxide gas, hydrogen, oxygen gases, things like that. But you will see bubbles form, so it's a pretty obvious one. Next up, we have certain reactions will be reactions between two different solutions, so it looks like you're just mixing two liquids together, and then a solid forms from the two solutions. Okay, in this case, the solid would be called a precipitate. So if you have a solid drop out of a solution, okay, it means that it can't dissolve in water, then that is going to be another indication that you have a chemical reaction taking place. When you see light or heat released, okay, that is a pretty good indication that you've got something chemical going on in there. And then also when you have a color change. So that word right there is phenolphthalein. It will actually change from colorless to pink in, I believe it's bases. Okay. So if you see bubbles, a solid forming, light or heat released, or a color change, those are pretty good indications that you have a chemical reaction taking place. So there is a video. It's a bit dramatic, but I have this one posted. It's called Pharaoh Snakes, or the reaction is called Pharaoh Snakes. This is actually listing out the reaction that takes place. It's between mercuric thiocyanate and ammonium dichromate. Okay, so it's a bit dramatic because of the music that they have with it, but it is actually a pretty good reaction. They have it layered in a very specific way to get the different stages of the reaction that you'll see. And this video kind of amazes me because this is actually kind of a toxic reaction, so they don't have it in a closed fume hood, which is kind of a no-no. But alright, so that is it for this video, and we'll pick up on the next video.